Hi, this is Harish here. Welcome to DB2 UOW Tips and Tricks video tutorial part 167. In this tutorial, I'm going to talk about the tip that I'm going to provide is what is UOW or unit of work or transaction, client idle wait time. The scripts that I'm using, the data files that I'm using are available for free download at db2lewacademy.blogspot.com. Please subscribe to my YouTube channel, youtube.com/db2lewacademy. This is a problem scenario. We want to understand what is UOW, client idle wait time. It is a metric or it is a measure of idle time between database requests. So suppose if you're connecting to a database and you're issuing a query. So when the query gets completed, after that the application is kind of idle. And let's say if the transaction is not committed or rolled back, so then the transaction is active or the unit of work is open. So it's called as open or uncommitted transactions. So the duration of open or uncommitted transaction is what you see as idle time, or it's a measure of idle time within a unit of work. It's not across unit of work. So sometimes you will issue the query, you will commit it, so which means the unit of work is completed, and then the application will remain idle. That is different. That is application idle time. This is an idle time within the unit of work. So I will execute a query. I will not commit or roll back. It might be an update, insert or delete or select, whatever, but I will not do any commit or rollback. So there is an impact on performance because there will be locking involved, log file management, recovery, overall performance. It helps in overall performance. The general guideline is, if you want to achieve all these things, no transactions should be open for a very long amount of time. So you should, in a particularly OLTP, like the transactional based system, you should issue a commit or rollback. The application should issue a commit or rollback as soon as possible. And sometimes it is also preferred to have the auto commit flag on, but it depends on the application nature. So not every query that is submitted to the database should be committed. So it lot depends on the application design or the application requirement as well. But even in that case, from an application design, it is always good to minimize this duration of open or uncommitted transactions. So that is what I'm going to show in a demo. So just to see how we can monitor this and how we can get this. So for that, I have already started the instance. I have activated the database. I have connected to an RHEL system using SSH, and I have connected to the sample database. And there is a monitoring routine available to figure out that. So this is the query: select application handle, UOW ID, client idle wait time, and I have divided by 1000 so that it will give it in terms of seconds. So I'll copy that query and let me just paste that and run. So this is now this current application, which is 20. So you can see the application idle wait time is always 0 because it is in auto commit mode. Okay, so let's open another terminal and give a few more connections like that. So here what we'll do is we'll connect SSH db2 luw @rhel-01 $786. Okay, let me connect to the sample here, same database, and let me check. Yeah, so I have a table here. So already I have created the table UOW1, and I'm going to run the UOW1 insert record. Just I'm going to insert one record here. Okay, and I have not committed this transaction. So if I go here, you can see now there are two applications. One is 20, which is the current application from this window. 29 is the one which got connected from over the other one. So you can see the client idle wait time is increasing by 11 seconds. And if we wait for some time, again the client idle wait time will increase to 22 or something. Yep, it increases in terms of 11 seconds. I'm not sure why though, but 22 then. So this is the idle time that I'm talking about. So I'm not even committing or rollback. So 12 seconds now. So it has increased another 12 seconds. So for we can understand for the past 34 seconds that application, there is a UOW start time, right? So it has not for the past, so we can almost assume 39, right? 1839, and from 1839 it did not, for the next 45 seconds it did not issue any commit or rollback. That is what we should understand. So if we can look at another terminal and we can run the same command over there also, like for example where is my another terminal? So this is uncommitted. So I'll go here, terminal, I'll open another tab. So I'm going to say SSH db2 LUW. This will be my second connection at the rate RHEL-01 $786. Okay, so again connect to sample. Again the same insert query we will run. Where do I find the insert query? Okay, so this will be the insert query. So again I'm not committing or rollback, so you should see now two applications, right? Yep, so this is 102, which is the first application 29, and it is ordered by the client idle wait time. So you can see that now the second application 30. So 29 was the older application, 30 is like the recent one, and it is idle for about and it is all increasing. So 125, 12, 23. So it 10 to 12 seconds, I think it is incrementing. It's increasing the counter for every 10 to 12 seconds or so. So 125, from 125 it became 136. You can see how long it is idle. You can open another application too if you want, like so how do I go there? Okay, so I'll open another SSH session if you want. So open tab, and as soon as you commit or rollback, you should see the timestamps reset. So we'll see that. Okay, so I'm going to insert a record. Let me see. Okay, so another insert I have done. So let me see here. So now there are, see, these three applications are there. This is 183, oldest application, which is idle for a long time. 82, which is the next application, which is idle for 82. So this is more than 3 minutes. This is more than 1 minute, and this one just recently started, so 12 seconds, like that. So what we'll do, we'll close one of the oldest applications, so we can roll back the transaction. So as soon as I roll back this transaction, you will see that the application number 29, right? See, that has come down here. Okay, so the client idle time got reset. Okay, so it's like 0. From 205 it became 0 because I rolled back the transaction. Then obviously this is the next application which is holding the longest idle wait time. This is the next application which is holding the longest idle wait time. So this way you can identify what. So this is now rolled back, so I can even connect reset and exit. Okay, so now you can see now the 20 itself is gone. Oh sorry, 29 itself is gone. So now 30 and 31 are there, and they too are the oldest applications, and it can be in any order, right? So for example, I'll close this guy, which is the latest application. So I will roll back. You can even commit also. It's not like you should roll back. I'm just rolling back for the convenience. So I don't want any records to be there. So you can see that also stopped. So 31. So that one got stopped. There is a UOW stop time you can see. Once the application is rolled back, then I can connect reset. So this is like the timely closing of the transaction. So now you should see only one application which is there for more than 3 minutes. So which I can again roll back. So if any application has started a unit of work and it did not commit for a long time, then you can use the okay, now I have closed everything. So there are no applications and which is having idle time, and mon get unit of work, I am passing null to display all the connected applications, and I am ordering by the client idle wait time descending order. So this way you can track what applications are idle for a very long time, holding up your transaction or not committing the transaction or roll back like that. So this is the most simple way to access that information. Hope this information was useful to you. See you in the next video tutorial. Until then, bye-bye.